Hey, listeners, welcome back to Sustainability Street, our podcast on the intersection of commercial real estate and the world we live in. This episode is about embodied carbon. There was a time not long ago that tackling embodied carbon took a back seat to reducing operational carbon. The research on materials wasn't there, and the wins with operational carbon were considered easier and more economical to achieve. Today, that's all changed. There are an array of tools for measuring the carbon in materials, and environmental product declarations, or EPDs, are now standard in the construction industry. And the word is spreading that building sustainably does not have to mean higher costs. My guests for this episode are Rebecca Esau, a manager with the Carbon Free Buildings Program at the Rocky Mountain Institute, and Tolga Tutar, Senior Sustainability Director for Skanska. They're going to be discussing their recently co-authored report, Case Studies in Cost-Effective Low Embodied Carbon Buildings, which demonstrated how embodied carbon in buildings can be reduced without raising costs. I think you're really going to enjoy our in-depth discussion. Hi, Rebecca and Tolga. Thanks for joining me on the podcast.
Hey, thanks for having us. So happy to be here.
Hello. Yeah, thanks for having us.
Why don't you start? Please introduce yourselves to my listeners and tell us about how your firm or organization has been engaged with the study of embodied carbon and best practices for reducing embodied carbon in construction.
Sure. Well, hey, everybody. My name's Rebecca Esau. I'm a manager with RMI's Carbon Free Buildings practice. If you don't know about RMI, we are a clean energy nonprofit. We work around the globe. We work to kind of transform energy systems, which includes buildings. And we're really just working to build the clean and prosperous and zero carbon future that everybody wants to live in. And I'm an architect by training. I've been working on embodied carbon in buildings since 2020. And our work at RMI really includes a lot of kind of policy and standards work. We are making sure that we have kind of trustworthy and consistent data for reducing embodied carbon in buildings. We're working in finance to help unlock new revenue streams to kind of cover any upfront green premium that comes with these things. And really what we're trying to do is help arm the practitioners and stakeholders with the tools and resources they need to implement low carbon building practices, both in their buildings and across their portfolios.
Okay. And Tolga?
Thanks for having us again. Happy to be here. I'm Tolga Tutar. I'm Senior Director of Sustainability at Skanska. We are one of the world's largest construction and project development companies, known for our leadership in delivering complex building and infrastructure projects, with a strong emphasis on innovation, sustainability, and operational excellence. And we are widely recognized for our leadership in sustainability and decarbonization in the built environment through low carbon construction practices, and also integrating environmental performance into our core business strategy. Regarding embodied carbon or carbon emissions overall, in 2015, we set an ambitious industry-leading science-based target to achieve net zero carbon emissions across our own operations and entire value chain by 2045. And we have established also aggressive interim targets to reduce these emissions about 70% on our operations side and 50% across our value chain by 2030, measured against our baseline years. So utilizing low carbon strategies and reducing embodied carbon in project level is kind of central to our corporate commitments and our core business strategy. And these efforts also align with the evolving expectations of our clients and current and upcoming regulatory changes. So in my role, I work closely with our planning, leadership, and operations teams to innovate, think a bit outside of the box, and identify like cost-effective, feasible, and impactful sustainability strategies to comply and exceed our clients' goals. And for that work, we partner with many subject matter experts like RMI in the field. I am an architectural engineer by training, and back in the day, I had the pleasure for working for RMI, so I'm a proud RMI alumni. So we are happy to continue
That's
our
great.
collaboration to date.
So before we start talking about your eye-opening study, let's set the stage a little bit. I think 10 years ago, embodied carbon was considered something that was hard to calculate, and um, reducing embodied carbon was thought as something that would add a lot to a construction project. Talk about then, how we got from then to now, and what now looks like with embodied carbon.
Yeah. Well, I think the industry in general like has a lot more data and tools and knowledge to drive impact in this space than it did 10 years ago. And really, you can kind of see a shift in industry awareness, I think, that was really happening during this time where project teams started to look beyond just operational energy efficiency in buildings towards embodied carbon and beyond thinking about like, okay, concrete and steel as individual materials that we can kind of leverage to decarbonize our buildings, to kind of looking at the whole life cycle of a building, thinking about design strategies that can be implemented and material efficiency and how embodied and operational carbon kind of work together or interact with each other. And so I think just in general, there's been a lot more discussion in the industry, kind of the level of kind of literacy and knowledge has grown substantially. And I think that kind of market demand has really helped drive data disclosure. It's a little bit of like a chicken and egg problem, but I think, we've had programs like LEED, Living Building Challenge, and then government policies like Buy Clean policies, especially, which we started to see kind of crop up in the early 2020s, either requiring or requesting EPDs for materials from suppliers. That has really helped kind of drive the data foundation for this kind of measuring and tracking embodied carbon in our buildings. And so developers and architects and contractors that were asking for them, for material manufacturers to provide EPDs, there was kind of a momentum that started to build to that, and manufacturers started to respond. And then, of course, like once EPDs are out in the world, they're accessible to everyone, and there's competition for other manufacturers to include EPDs and reduce their embodied carbon. So yeah, I think we've just seen a lot of momentum around that whole kind of data landscape. And then, of course, we have new tools that came online like early in the last 10 years. We had the EC3 tool, which is like a free accessible tool where you can research and find different EPDs from manufacturers. There's Tally and One-Click LCA, which help integrate whole building life cycle assessments into practitioners' workflow more easily. And so I think the tool aspect has really helped project teams execute measuring and reducing embodied carbon in buildings more easily too. And that's helped a lot in kind of arming people with what they need to make impact.
Tolga, do you want to add to that?
I think Rebecca covered well, but I think the main change over the last decade has been the understanding of carbon footprint of buildings. Because for many years, like when we talk about decarbonization efforts in the built environment, we were primarily focused on what we call essentially reducing operational carbon emissions, like improving energy efficiency of a building, optimizing building systems, and transitioning to more cleaner, renewable energy sources. And while these efforts have delivered like meaningful progress, they only address part of the total emissions footprint of a building or infrastructure projects. And over the past decade, there has been a growing recognition that embodied carbon is equally critical. The emissions associated with material extraction, manufacturing, transportation, construction, all the decisions are equally important as operational carbon emissions. And when you want to improve a metric, you have to create a baseline for yourself to measure against. And when you don't have data, it's very hard starting point. So all the improvements have been made from data perspective has been super helpful. And we kind of transitioning now from voluntary action, from innovators, targeting like very stringent green building certifications like ILFI zero carbon or LEED, to more like mandatory requirements by upcoming policies and regulations. So it will be more impactful change in the next decade in comparison to previous 10 years, probably. To Rebecca's point, there are so many different tools and platforms that we can utilize and better understand our project's environmental footprint and embodied carbon baseline. EC3 definitely has been an instrumental. Skanska co-developed a tool with Microsoft, Carbon Leadership Forum, Sea Change Labs, and many other industry partners down the road, and it's now publicly available, actually since the end of 2019. And thousands of users are utilizing the tool to better understand their baselines, benchmark themselves, and find solutions for their projects. And on top of that, I guess it's important to underline RMI and other amazing institutions, research, publications, and case studies. The more we share, the more we can learn from each other and we can go faster together. So that has been a fundamental shift in the last decade from embodied carbon perspective.
Yeah, and I think you said in our previous discussion that buildings account for 39% of carbon and embodied carbon is 11% of that, I think you said.
Yeah, so it's a big chunk of the pie. And if you think about, we're starting to build more and more efficiently, right, in terms of operational carbon. So we're doing all the very much needed and necessary work to help improve operational carbon. But if embodied carbon goes unaddressed, it's going to take up a huge piece of that life cycle emissions pie. So yeah, I think there's a lot of attention on this in the industry, and it's been wonderful to see kind of the progress and momentum that we've been able to build together. As Tolga said, I think it's just a really cool community of NGOs and practitioners working on this and passionate about it, and that's one of my favorite things about working on the topic.
Okay, so let's talk about your study, and it really I'm going to let you explain it, but kind of the gist of it was that controlling embodied carbon doesn't have to cost more. So I'm going to let you go ahead and explain that. Rebecca, do you want to start?
Yeah,
talking about that?
Yes, this project. So actually, one of my first projects when I came to RMI was working with Tolga. And we published a joint report with Skanska called Reducing Embodied Carbon in Buildings. That report looked at low cost and high impact opportunities to reduce embodied carbon. And we presented some of Skanska's work that kind of gave evidence to that. So the report that we're talking about today is essentially like a follow-on report where we did really want to kind of test the economics again and understand how the cost impacts for designing and building low embodied carbon construction kind of plays out today. And we also wanted to show kind of what we just talked about is like how the ecosystem has matured and how there's so much more momentum towards standard practice within embodied carbon in the industry. So really the report, it kind of pairs those market insights and kind of like a summary of embodied carbon in the US over the last decade with 3 case studies built by Skanska. And these are case studies of real built projects. And the results of those case studies really do demonstrate that embodied carbon, it of course is environmentally necessary for us to start reducing, and it can be economically feasible and even in some cases advantageous, where it's actually providing cost savings to the overall project budget compared to kind of a business as usual construction. So really our report is helping to kind of demonstrate and call out those like win-win solutions where both cost and carbon in building design can kind of like you can have a big impact through that, but then also that, as Tolga mentioned earlier, like embodied carbon reduction it's no longer really a nice to have. It will soon be a requirement in the industry. And in some parts of the US, it already is, including in California. So I think what our report really does well is that it shows that there are these low-cost solutions that are available to practitioners today, and you can do this very effectively, and you will be able to comply with these future requirements in a cost-effective way, and that it is actually advantageous to you to kind of explore these solutions as, you know, as each project develops over time, because there's lots of really cool opportunities to do this.
Tolga, do you want to add to that?
Sure. I guess long story short, to Rebecca's point, like our goal for these two reports to fight against the stigma with the saying like embodied carbon or low embodied carbon buildings come with a cost premium or always cost more. That's not true anymore. There are really lots of best practices. And if you go out business as usual and implement some of those embodied carbon reduction best practices, meaningful embodied carbon reduction targets can be achievable in cost parity, even with low cost options. And to Rebecca's point again, like we have collaborated on two different studies. It was a great teamwork. Probably when I have a chance, I have to thank some others, like Mark Chan and Steve Clam from our team, Matthew Klaus, Victor Oljai from RMI, and many others have been part of this. So it was a great teamwork. In the initial report, we focused on different building typologies mostly and showed that even for any kind of building type, meaningful embodied carbon reductions can be achievable in cost parity or with very low cost premiums below 1%. And in this case study, and in this research, we have approached this a bit differently and focused on different embodied carbon reduction strategies and highlighted those impactful strategies and how they can both lower cost and both lower the embodied carbon footprint of a building. But overall, this current research showed that meaningful embodied carbon reductions like 20-50% range can be achieved at little and no cost premium if the discussions start early on, if teams work together on evaluating different practices and have a chance to identify like low cost, high impact options. And material substitutions, design efficiency, early coordination, along with all the novel like upcoming technologies coming into the market, can work hand in hand and can really push the limits to like ultra high like embodied carbon reduction for both building and infrastructure projects.
So let's talk about some of the case studies.
Yeah, well, I can kind of tee up Tolga to talk more in depth about the case studies, because really these are wonderful projects from Skanska that Tolga and team worked on. We wanted to show, I think they show a really nice variety of different types of projects. So one of the case studies is an adaptive reuse project for the University of Washington. It utilized an older building, and Skanska did an assessment between kind of what the adaptive reuse would be versus kind of a new build scenario. And this case study found that the renovation of, retaining the existing building and turning it into an adaptive reuse project, it was able to reduce the embodied carbon emissions by 77%.
Wow.
And then there was a 46% reduction in cost comparison to the new build scenario. So that's huge. And then the other case studies, the second one is around kind of the process around bid leveling. So it kind of describes how Skanska incorporates embodied carbon into its bid leveling process when you're evaluating kind of the carbon performance of a material alongside all of the other requirements that are needed to achieve the project success. And then thirdly, the last one is around structural design. So it's a comparison between a typical steel frame construction and then mass timber, where Skanska found that mass timber reduced embodied carbon emissions 78% compared to, the typical steel frame construction. And here there was a cost premium overall with the project, but it's very small. It's only a little over 1%. With the overall project budget. And so there were other things that Tolga can talk about that were appealing for the developer to move forward with the mass timber beyond just the kind of emission savings that they achieved. So yeah, they're really compelling projects that were built, and maybe Tolga can talk about a little more about each one and kind of the details.
Sure. Yeah, thanks for the overview, Rebecca. Yeah, when we started this research study with RMI, we look for many different potential case studies and projects and try to not to cherry pick the ones that are actual targeting embodied carbon, but have some generic sustainability goals, but also achieve substantial embodied carbon reductions on the side due to different strategies implemented. Maybe I can start with the mass timber.
Sure.
It's definitely becoming a hot topic right now. Mass timber is a great alternative material. Most of the time, we look for reinforced concrete or steel options for structural systems, but mass timber is definitely making an impact. And when it's coupled with sustainably managed forest practices, it can make a huge reduction in overall embodied carbon footprint of the project. So we probably to date completed around 30 mass timber projects, so we are heavily investing. But it's important to underline when we are, I guess, selfishly, all sustainability consultants are looking for this magic material and solution. But it's important to underline there's no silver bullet. Every project is different obstacles, different opportunities. But yeah, in certain cases, mass timber can be highly impactful in reducing embodied carbon at cost parity. And in this particular case study, for a very special educational building, our client had been interested with mass timber from biophilic features perspective, because it was visually appealing, it was really comforting, and it was really enhancing the building occupant comfort for that particular project. But on the side also, it's modular. It can shorten construction timelines, and in this case, it can also be very impactful in reducing embodied carbon to traditional steel. The other case studies, adaptive reuse is another hot topic. Maybe we can dive deeper later, but comparing to new construction, it's always a dilemma for developers. Should we demolish the entire building, start from scratch, build new with all efficient systems, or protect a portion of it, maybe keep the foundation, facade, etc. There are many different benefits for adaptive reuse, but from embodied carbon perspective, I guess it's important to acknowledge the building with the lowest embodied carbon footprint is the building that we already have, right? You don't need additional materials, you don't need to demolish and think about it. So adaptive reuse will gain more momentum, I think, in the near future to navigate around cost volatility, urban infill demand, faster permitting, but also from embodied carbon perspective. And the third case study, we look for more standard practices and how we can make it more like a best practice from embodied carbon perspective. When we select our suppliers, vendors, we go through a bid leveling exercise to compare different suppliers, apples to apples, from cost, technical performance, schedule perspective. And as a standard practice, we now add carbon to the metrics. So we demand for their published environmental product declarations, what kind of products they are offering, and we lay down carbon layer on top of everything else. And we select our suppliers based on that. And we also provide this information back to the suppliers, so it will be a great lessons learned for them. So we are kind of sending the message back to the industry. You will be evaluated based on your products' embodied carbon footprints for our next project. And they are very receptive. I mean, they are their subject matter expertise in their own industry, so they always come up with great solutions. But it's important for general contractors, developers to ask about carbon information in the procurement and bidding process. So our case study basically find out that that will be very impactful.
Okay. Yeah, mass timber is certainly having its day. Are there other materials that are kind of emerging in recent years that are delivering significant savings?
Yeah, maybe I can start on that, Rebecca. But yeah, it's exciting times because there's so much momentum in the industry coming from different manufacturers and industries. Mass timber is one of them. Again, when it's coupled with sustainable managed forest practices, it can be very impactful. Concrete products or steel products seem like the problem child because traditionally they are really highly carbon intensive in manufacturing level, but they also present a great opportunity to make an impactful reduction. Low carbon concrete is a hot topic for sure. Many suppliers coming out with their low carbon ready mix products to the market. Cement is a key ingredient in a concrete mix, and although it represents maybe 10% by weight, it represents 90% of the carbon emissions in a concrete mix.
Oh, wow.
So cement replacement type products is gaining popularity. And we have been using them for decades for cost reasons or technical reasons, but they can be impactful from embodied carbon perspective as well. So like fly ash coming from power plants as a waste product, steel slag coming from steel manufacturing facilities as a waste product, or glass pozzolan, for example. Those are great alternatives and replacement for cement. And there are many startups coming up to the market with their new innovative novel products that can go beyond lowering embodied carbon, but can be even carbon negative. So it's important to utilize those products as well. On the steel front, specifying steel products with high recycled content to lower like virgin raw steel materials is important. Being mindful about suppliers and looking for manufacturers that can utilize what we call electric arc furnaces. That is a very energy efficient manufacturing process. So it's important to be mindful about that. About more basics, like material efficiency is very simple but very impactful design process. It's important for design consultants to work together and identify opportunities to reduce or eliminate the material need in the first place. Prefabrication, modular building systems can be very impactful to reduce waste, accelerate the construction schedule, and reduce like construction related emissions. On the envelope, low carbon insulation products are coming to the market, like bio-based materials like wood fiber or hemp-based insulation products are coming into the market, and they are like carbon negative. We see many different finishes with the same trend, like carbon negative carpet tiles, etc. So overall, like all these products together can make a really substantial impact in the overall embodied carbon footprint of a project. And when designers think about those strategies early on, it can be cost effective as well.
You've mentioned a couple of times about early planning. What are the benefits of starting this really early, and what are some of the things you can, the foundations you can lay by starting early?
Yeah, I do think like starting from the get-go is really important. We've started to explore how developers can integrate embodied carbon assessments into like very, very early financial assessments through their pro forma tools, and then early decisions like how big is my building and is there an underground parking lot or not, and what is the structure of it, and
Mm-hmm.
should I reuse this existing building or demolish it? And those decisions are so critical, and they also come with like, kind of there's a narrow window in which you're making those decisions, and you're also analyzing all these other pros and cons, like especially cost factors and such. So
Mm.
if you're integrating carbon into those assessments from the get-go, you will be able to make a more informed decision. So I think, yeah, the earlier the better for that. And maybe Tolga, you can talk a little bit more about like how that actually plays out in practice and how you're seeing that come through in the projects that you're working on.
Sure. Yeah, I mean, we cannot stress enough how important early planning and integration is. And it's not just embodied carbon, anything around sustainability. When it becomes an add-on item later in the stage, then it comes most typically with cost premiums because you ran out of all the low-hanging fruits or best practices. Now it's too late to change anything. And yes, it will cost more to you. And that's where the stigma comes from. But in terms of early planning, it really starts with the early decisions by developers, owners. Even the contract type they are selecting can make huge impact. Like traditional design build type of contracts where design team is siloed doing their own thing and they look for contractors and then award the project to a contractor and they come in a very later stage. That's so siloed and isolate these two very important parties, and it can really impact the cost and carbon outcome of the project. But more holistic contract types like IPD, integrated project delivery, or design build type of projects can bring in owner, designer, design consultants, contractor, and specialty subcontractors to the table so they can have these conversations early on. That's where it starts. In the conceptual design, it's really important for designers to kind of implement a whole building lifecycle assessment to kind of create a baseline and target for themselves and to work against that target throughout the process until you are at as-built construction
Mm-hmm.
phase. And in a very high level, yeah, reuse versus new construction, you can have those conversations, right? And then like the building form that might lead to material efficiencies, those are in the early design phase. Then you start digging deeper. Okay, I know my form, it's going to be new construction, but structural system represent probably 50% plus of my embodied carbon footprint. So should I build steel, reinforced concrete, mass timber? Then you can look for those kind of design decisions from cost, technical perspective, or carbon perspective. And bring in design consultants, like now maybe you are working on your facade. MEP engineer and energy modeler can bring in really good ideas. Maybe you are thinking, I would like to increase my insulation level, but now I have more materials, so embodied carbon will go up. Is it really the case? Maybe you can coordinate with the MEP engineer. They can downsize the mechanical system because you are reducing your heating, cooling loads. Smaller mechanical system, smaller embodied carbon emissions for MEP systems, potentially lower amount of refrigerants, which are also another topic we should discuss probably, and more operational carbon savings down the road. So to identify those kind of opportunities, that conversations need to happen between parties and carbon should be the common language. And then once you go through that design phase, now you're in procurement phase, working with your contractor, your suppliers more granularly, and then you can focus on material specifications, right? Specifying like low carbon materials with either higher embodied carbon thresholds or more maybe in project level performance requirements that can make a difference. And to the point we discussed about case study, with those specifications, you can implement a very smart procurement process through bid leveling, again, comparing suppliers for their product solutions from carbon perspective, and then going through this process and just updating all these assessments with as-built quantities and materials so that you can use that project data as a lessons learned and a baseline for your next project, and you can build upon that. I think that's pretty much the whole life cycle of like design and construction process. And the earlier you start on this journey, the more opportunities that you will identify for impactful embodied carbon reduction, but also cost savings potentially on your project. So yeah, early coordination is key.
And I'm sure everything is important, but is there some part of the building that people should put more of their focus on? Is it the floors, the walls, the finishes? Like where's the biggest spend in embodied carbon, would you say?
The structure, right, Tolga? Would you say?
Yeah, I guess I don't want to blame structural engineers, but
It's
due
not
to
their
the
fault.
due to the highly carbon intensive materials, at least traditionally like concrete, steel, and higher quantities of those materials, structural systems in a new construction build represent a big portion of your total project embodied carbon footprint. Then probably envelope comes in, then interiors. For a tenant improvement, for a renovation, okay, it might depend. And thinking about other project types like data centers are on the rise. For those kind of projects, MEP systems can be very impactful in terms of identifying lower carbon options because, yeah, the scale for MEP systems are pretty huge, and refrigerants and refrigerant leak impact on the overall embodied carbon footprint of a project is important. So it's important to have these conversations a bit more often and early with MEP designers and specialists.
So what's next for embodied carbon? What's the next phase in the knowledge journey or the next phase in reduction strategies?
Yeah, there's so much here to talk about. Tolga, I'm glad you brought out data centers. We are looking into that just because there's such a huge boom in construction that we're going to be and are experiencing currently in that area. I think in the US, like one thing that really excites me as a person working in this space is kind of the carbon storage that we might be able to achieve through building materials. So this is where we can use natural or bio-based materials that, have naturally sequestered carbon and then use them in our buildings. And then those buildings kind of act as carbon repositories for however long those materials are in place, essentially, in the building. And this is really exciting to me because we always think about buildings as like carbon liabilities and carbon problems and I think we can, flip the script almost where buildings are actually more of carbon asset or climate asset to our communities. And so we're looking into this a little bit. We're looking at bio-based materials, so materials essentially that are made from natural materials like wood, hemp, straw, paper, biochar, even for concrete. And this is it is like adjacent to the timber conversation. Like timber is absolutely a bio-based and carbon storing materials, but what we're looking at RMI is more around kind of products that are made from waste materials. So like wood or timber thinnings from forestry management and like leftover hemp and straw materials that would otherwise be disposed of or incinerated somehow. And I wouldn't say that, these materials are booming in popularity yet, but we see this really big possibility of essentially converting these materials into like valuable building construction components, like, a wall panel component or insulation or flooring. And so my colleagues in 2025 put out this report. It's called The New American Harvest. And they were able to quantify that we could store 100 million metric tons of CO2 with these materials from waste products in agriculture and forestry. And then that would essentially generate $79 billion in new manufacturing opportunities, and that could translate into over 300,000 jobs. So we do really see this as like a big, exciting and untapped opportunity where we can use these waste materials for good, and we can use them in our buildings, and they create healthy building environments. They help us support our circular economies. They generate revenue for farmers and other folks. And they also would store carbon, which is going to be needed in the
Yeah.
energy transition and to meet our climate goals. So that's the most exciting thing on the frontier for our team at RMI, and it's something that especially gets me excited about things.
I look forward to that. Um, Tolga, at Skanska, what's the future look like?
I think future is exciting. Yeah, we can probably have a 8 hour long podcast, but couple of items. Definitely, like we were talking about operational carbon emissions and embodied carbon emissions, but now they go hand in hand. So there's
Yeah.
a shift for more whole life cycle carbon optimization. The upcoming regulations focus on that, like the new version of LEED version 5 have requirements for all life cycle carbon optimization. That's exciting. Digital integration, we talk about lots of tools available now with the power of AI. Now they can work with each other. We can better optimize design. We can get access to better data and make decisions much quicker. So we are going through a learning phase, and I think next couple of years we will see the impact of it. Many different startups coming up to the market with very innovative novel products. I think next phase will be supply chain decarbonization at scale. It's important for developers, project owners to kind of give an opportunity to those companies because they need to pilot these products, show the real impact of it, optimize the product, and it's economies of scale. With that information, they can scale up their production, and those products will be available in the market in the near future in a more cost-effective manner. And maybe another item that excites me is the circularity and deconstruction, or design for deconstruction, is gaining popularity. Right now, the focus is more about materials and transportation construction emissions, but another important chunk of embodied carbon is end of life emissions. And we are right now making wild estimates what's going to happen to this building in 6 year lifespan. But it's important for manufacturers to think about it, like design assemblies, components, materials that can be easily broken down without any special tools, or not glued together, but maybe mechanically fastened. So GCs like us doesn't have an issue 6 years down the line and cannot separate materials or couldn't find feasible recycling or reuse opportunities. So this will be important for the manufacturing industry moving forward.
Okay, well, thank you so much for this discussion. I always ask my guests, where can my listeners learn more, you know, um, organizations or podcasts or reading material. Your study will be helpful, but
Yeah,
any
read our study.
anything else that comes to mind?
Well, shameless plug for rmi.org. We have a lot of resources. You can visit our Embodied Carbon landing page, or follow Carbon Free Buildings on LinkedIn, where we're going to post all of our resources. I think, another wonderful partner that we work with often is Carbon Leadership Forum, or CLF. And they are just excellent. Their website has a lot of amazing resources, both for, I think, if you're very new to the topic and you need kind of a 101 level education for yourself, or if you're looking for more technical and in-depth resources, they have it all. They also have regional chapters that run meetings and events locally. So they're just a really great community to kind of plug into, as if you're embodied carbon curious, or if you are already kind of an expert in the space. Tolga, any other suggestions?
Also, selfishly, probably I can recommend Skanska website. Skanska Foresight podcasts are really one of my main resources. We always happy to share our best practices. We are an open book, so if anybody is interested, please reach out. Let's brainstorm on projects together. In addition to RMI and CLF websites that are also my main resources, Building Transparency website is a great resource. Our colleagues at BT own and continue developing EC3 tool, but there are so many good publications and resources in terms of like low carbon specifications templates, different guidelines and summaries and frameworks. So that's a great platform. Sustainable Construction Leaders Group is also another platform that we kind of depend on. I'm very active in the Bay Area Sustainable Construction Leaders Group, so it's important to get engaged with your local regional hubs, learn from others, learn from your peers. I think those are my go-to resources. And many of our like high-tech clients also share their best practices and reports and research on their own websites. Like Amazon, for example, recently published the Climate Smart timber and wood supply chain research based on some of the lessons learned from Portland International Airport with CGF, with us, with Sustainable Northwest. So those kind of like best practice and case studies can be really impactful, I think, because those are the real life experiences and includes all the lessons learned for future projects.
Okay. Well, thank you very much, both of you.
Thank you so much, Therese. This was so fun. I appreciate you
Thank you for
inviting
having
us.
us.
And thank you, listeners, for joining me on Sustainability Street. If you have any questions about this episode or suggestions for future episodes, please reach out to me at therese.fitzgerald@cpe-mhn.com. And don't forget to rate and review us on Apple Podcasts and Spotify. Bye for now.